Welcome to the DIY Honda Garage channel. DTC P2826 indicates a problem related to the electrical circuit of line pressure solenoid valve A in Honda Odyssey models from 2011 to 2017. This diagnostic trouble code signals a short in the circuit, which not only affects the functioning of the solenoid, but can lead to significant issues in transmission operation. The line pressure solenoid valve A is essential for controlling hydraulic pressure within the transmission, directly influencing gear shifts and overall performance. In this case, the vehicle's transmission remains mechanically intact, but an electrical issue is causing the DTC to trigger. It's critical to utilize the Honda Diagnostic System, HDS, to gather relevant freeze data and onboard snapshots prior to attempting repairs. Understanding that this DTC is strictly electrical in nature, separate from mechanical problems, will streamline the troubleshooting process significantly. The error represented by DTC P2826 indicates a short circuit in the line pressure solenoid valve A, circuit in Honda Odyssey models from 2011 to 2017. This circuit is crucial for managing the pressure within the transmission, which is why any electrical faults can lead to poor transmission performance. Located within the vehicle's transmission system, the line pressure solenoid valve A determines hydraulic fluid displacement, thereby affecting gear shifts. The state of this component harnesses electrical signals to create changes in hydraulic pressure. Identifying the source of the short is imperative because the DTC explicitly states that it occurs due to an electrical issue rather than mechanical failure. Before any troubleshooting, ensure to accurately record all freeze and snapshot data using the Honda Diagnostic System, or HDS, which can give valuable information on the system's previous performance and faults. DTC P2826 arises primarily due to various electrical circuit issues within the vehicle. A prevalent cause is a short to ground, where electrical pathways connect inadvertently with the vehicle's body or other grounding points, leading to erroneous signal readings. This type of fault can often result from damaged wiring or poor connections, which may occur due to wear, corrosion, or physical stress. Additionally, connector damage at points such as the PCM powertrain control module can also trigger such a DTC, highlighting the importance of ensuring secure and intact connectors. It is crucial to delve deeper into each potential cause during the troubleshooting steps to conduct a thorough assessment. A methodical approach to identifying and rectifying these electrical issues will restore the intended functionality of the line pressure solenoid valve A, while ultimately clearing the DTC. The symptoms associated with DTC P2826 typically manifest through noticeable transmission-related issues. Drivers may experience difficulties in shifting, which can lead to jerky transitions between gears or an inability to enter certain gears altogether. Another telling sign is an error message displayed on the vehicle's dashboard, alerting the driver of a fault in the transmission system. Additionally, overall vehicle performance may decline, resulting in reduced responsiveness when accelerating or possibly leading to erratic behavior while driving. Identifying these symptoms early can prevent further complications in the vehicle's functionality. Observing the interaction with the Honda Diagnostic System can also be a vital step in confirming the occurrence of this specific DTC, as it provides a real-time report on vehicle status and faults. The first step in troubleshooting DTC P2826 involves turning the ignition switch to the on position, labeled as II. This action powers up the vehicle's electrical systems without starting the engine, thereby allowing for diagnostic tools to communicate effectively with the vehicle's onboard computer, specifically the Powertrain Control Module, PCM. Once the ignition is activated, it is crucial to clear the DTC using the Honda Diagnostic System, HDS. This process resets the error within the system and allows the technician to monitor for any new occurrences of the DTC. Clearing the code at this stage provides a baseline for evaluating any subsequent readings and ensures that the technician is working with the most current data available. Following these initial steps prepares the technician for more in-depth diagnostics. In the second troubleshooting step for DTC P2826, you should block the rear wheels and then elevate the front of the vehicle. This procedure ensures safety by preventing the car from rolling while the technician works on it, making it a critical measure in vehicle repair protocol. Once lifted, it is essential that the vehicle is securely supported, preferably using jack stands, to maintain stability during the diagnosis. This configuration allows for safe access to components that may require examination or testing. Additionally, raising the vehicle enables the front wheels to rotate freely, facilitating certain tests that may be necessary to evaluate the response of the transmission system once the engine is started. Adhering to safety standards during this step cannot be overstated, as it is paramount for technician safety. Next in the troubleshooting steps for DTC P2826 is to start the engine while ensuring that the brake pedal is pressed. Engaging the brake while starting the engine prevents the vehicle from moving unexpectedly, which is essential for conducting safe diagnostics. After initiating the engine start, shift the transmission into D for drive, and once in that position, release the brake pedal. This sequence allows the technician to observe the system acting under normal operating conditions. The shifting into drive and releasing the brake creates a typical driving scenario, providing valuable data on the performance and potential alerts related to the solenoid valve. Attention must be given to any anomalies during this procedure, as they may be indicative of underlying issues directly affecting the DTC. The fourth step involves utilizing the HDS to monitor the accelerator pedal position (APP) sensor while testing. The APP sensor is crucial for providing information about the position of the accelerator pedal, which the PCM relies on to adjust engine performance and transmission behavior. During this step, the technician will press the accelerator pedal until it's approximately 2% open, and then release it back to 0% every 2 seconds. This cycling action allows the HDS to capture changes in the APP sensor output, revealing any inconsistencies or malfunctions in the signal. By reviewing the data collected during this operation, technicians can better understand if the issue relates to the APP sensor rather than the line pressure solenoid itself. Retrieving this data is a critical component in determining if this DTC remains present or if additional faults are indicated. At this point in the troubleshooting process for DTC P2826, it is essential to check for any pending or confirmed DTCs using the HDS. A pending DTC indicates a fault that has been recognized by the PCM, but may not be constant. It signifies that a problem could occur again or might have cleared itself temporarily. Conversely, a confirmed DTC like P2826 is consistently present, signifying a steady problem with the circuit in question. If DTC P2826 is indicated during this check, follow through with additional diagnostic steps. If not, it suggests there may be an intermittent failure, and the system could currently be functioning correctly. It might not require further immediate action, but necessitates verification of connections, especially those between the line pressure solenoid valve A and the PCM. Moving to the next step in the troubleshooting for DTC P2826, turn the ignition switch to the lock position, which fully powers down the vehicle systems. After the ignition is off, The next action is to check the number B3 fuse located in the underhood fuse relay box. This fuse plays a significant role in supplying power to the line pressure solenoid valve A. A blown fuse could be a direct reason for the solenoid not functioning, thereby triggering the DTC. If this fuse is intact, it indicates that there are other electrical issues present in the circuit. It's crucial to refer to the vehicle's wiring diagrams during this step to trace any potential faults associated with the fuse and its related circuits, facilitating a deeper understanding of the electrical layout. If the number B3 fuse is found to be blown, this indicates a short to the body ground within the wiring that connects the PCM to the underhood fuse relay box. The integrity of this connection is vital, as any disruption can lead to malfunctions in the line pressure solenoid valve A. Therefore, the next course of action is to repair this short circuit and replace the blown fuse. Once repaired, recheck the system to see if new DTCs appear. This step underscores the importance of electrical integrity within the vehicle's systems and leads to a more reliable function overall. Ensuring a clean and solid connection between the PCM and the fuse relay box not only resolves the immediate fault, but also diminishes the likelihood of future DTCs arising from similar issues. The eighth step in the troubleshooting process requires jumping the SCS line using the HDS, which effectively allows the technician to manipulate diagnostic modes without having to affect actual vehicle performance during testing. This action isolates the PCM from other systems temporarily, providing clarity on where the fault may reside. Following this, disconnect PCM connector B, which houses numerous critical circuits related to transmission functionalities. This step is crucial as it prepares the diagnostic process for direct measurement and evaluation of the component and its related wiring. This preparation sets the stage for assessing voltage output and continuity, helping to pinpoint whether the problem lies within the solenoid circuit or within the PCM. As you progress further into the diagnostic process for DTC P2826, turn the ignition switch back to the on position labeled 2 after disconnecting PCM connector B. This step allows for the next critical measurement of voltage. Using a multimeter, check the voltage present between terminal B2 of the PCM connector and body ground. Terminal B2 correlates directly with the line pressure solenoid valve A's operation. If battery voltage is present, it implies that the circuit to this component is intact and functional. If no voltage is observed, this suggests that further inspections of wiring and connections are necessary. This diagnostic method is imperative to truly understand whether the problem is rooted within the solenoid or elsewhere in the circuit. Upon completing repairs related to DTC P2826, it is critical to clear all diagnostic trouble codes from the vehicle system using the HDS. This clearance resets the monitoring system, which allows new data to be collected under normal operating conditions. After clearing the codes, test the functionality of the line pressure solenoid valve A to confirm that it is now operating without faults. This can involve running the vehicle through various driving scenarios to see if any symptoms previously identified return. Verification is essential, as it not only assures the technician that repairs were successful, but also instills confidence in the vehicle's performance post-repair. A thorough check and confirmation eliminate the risk of recurring issues, ensuring that the remedial actions taken are effective. To mitigate future occurrences of DTC P2826, engaging in preventive maintenance is crucial. Regularly inspecting electrical connections, especially those connected to the PCM and line pressure solenoid, helps detect wear or potential issues before they escalate into significant problems. Corrosion or loose connections often go unnoticed but can severely affect vehicle performance. It is also advisable to routinely check wiring for signs of fraying or damage, as this is a common contributor to electrical shorts that trigger diagnostic trouble codes. Keeping these components in good condition promotes vehicle reliability and ultimately enhances the longevity of the transmission system. Remember, diligence in regular checks can save significant repair costs down the line, enhance overall driving safety and performance. In summary, DTC P2826 highlights a short in the electrical circuit of the line pressure solenoid valve A. Understanding the underlying causes, symptoms, and precise troubleshooting steps is pivotal for efficient resolutions. By closely monitoring symptoms and performing thorough diagnostics using the Honda Diagnostic System, technicians can accurately identify and rectify faults. Following each corrective step not only resolves the immediate code, but also enhances overall transmission function. Moreover, proactive preventive maintenance practices help ensure ongoing performance and reduce the risk of future issues. With a methodical approach, DTC P2826 can be resolved, ensuring the Honda Odyssey operates smoothly and efficiently. Please like and subscribe to the channel. See you next time.